I'm Ian Tatum. I'm a fisheries research project leader with Oregon Department of Fish and Wildlife, focused mainly on John Day, salmon, and steelhead monitoring. Today is October 2nd, 2023. We are on the lower John Day. We're about 2 miles upstream of the confluence of the John Day and Columbia rivers, and we're here to just check on some monitoring equipment that's monitoring migrations of adult steelhead into the lower John Day River. The John Day supports a wild population of summer steelhead as well as spring Chinook salmon. A phenomenon that we've noticed with the summer steelhead population is what's called overshoot, when the adult steelhead migrate past the mouth of their natal river and go further on up a main stem, the Columbia River in this case. And so I just wanted to note a couple of things about that and talk about a project that we're working on in collaboration with the Columbia River Intertribal Fish Commission, Trout Unlimited, Gillum Soil and Water Conservation District, and a whole host of other partners, including Oregon Watershed Enhancement Board and other funding agencies. So this is the lower 10 miles of the John Day River have been impounded since 1968. So now we're this broad expanse of water where there historically was a narrow, fast-flowing stream through here. Now we've got a river mouth that's about 100 feet deep in some places. While we don't have very good fishery monitoring data from pre-1968, we do have some anecdotal evidence from anglers and others that the steelhead migration in the John Day used to begin in September and really be going in earnest in September and October. But that's not really the case recently. For the past 2 decades, we've been collecting passive integrated transponder monitoring data that demonstrate the vast majority of the steelhead run that arrives at the mouth of the John Day. About 80% of the fish arriving at the mouth of the John Day migrate past the John Day and are detected crossing over McNary Dam, which is about 120 kilometers or 70 miles roughly upstream of the mouth of the John Day. And so those fish migrate over McNary Dam and spend days to weeks or even months upstream before they have to find a route to get back downstream through McNary Dam, back down through the John Day pool, and then back into the river to come up and stage for the winter before spawning. So the focus of the project we're out here working on today is to identify the specific individual migration patterns of steelhead at the confluence of the John Day and Columbia, and then see if we can identify A, where the fish are going, and B, how they're oriented in relation to current or the lack of current at the mouth of the John Day. And so really we need those data to understand if we can tell a story about the pattern of where fish are and what current patterns can be changed to influence their ability to find the mouth of the John Day during the fall and winter. Because it's our goal is to decrease the proportion of fish overshooting, because overshooting is a dangerous thing for steelhead because they have to go up over another hydroelectric dam and then find a surface passage route back downstream over that dam, which are not available 24/7, 365. And so if those surface passage routes are not available, then they have to migrate back downstream through turbines, which definitely causes mortality. So our goals are twofold. One, to figure out if we can identify routes or ways to manipulate environmental variables and keep more steelhead from overshooting and let them directly enter the river when conditions are tolerable. And secondly, just identify the patterns of migration upstream from McNary and other dams to see if there's better or alternate ways to provide safe passage back downstream for those fish that do overshoot. So we have 2 main types of tags that we've used on this project. The first tag is a smaller, what's called a passive integrated transponder tag, and so that's about the size of a grain of rice. And the key point there is it's a passive tag. So we can put those into juvenile steelhead when they're about 3 inches long and longer, and they stay in the fish mostly for their whole life. So that's a pro of that tag. The downside of that tag is that they have to swim over or near an antenna that energizes that tag. And so the read range, or the ability of our ability to detect that tag, is limited to within a few feet of an antenna. So that provides really good data when those fish go through narrow spots like small streams and rivers, or through the fish ladders at the Columbia River dams, which all have extensive network of pit tag antennas. But that doesn't work as well in the really broad areas of the impounded sections of the lower John Day and the John Day-Columbia confluence. So to learn about steelhead migrations at that point in the river system, we've used acoustic tags, which are a much larger tag, and they're an active tag that are sending out an underwater signal or an underwater ping. And then those tags are detected by a network of acoustic receivers that we anchor to the bottom in the deep water, or anchor to the shore in thermal refuge areas like the Deschutes or little white salmon or other places like that. So those tags are great because they send out an active signal that can go for 100 to 300 meters from where the fish is, but the tags are much bigger. You have to implant them only into adults, and they're much more expensive. So that's where this project is focused on coupling those acoustic tags with pit tags and placing those both into adult steelhead captured in the adult fish facility at Bonneville Dam. So we're trying to learn little snippets from each of those acoustic tagged fish about where they go, how successful they are depending on whether they go to cold water refuges or not, and then also track their migration patterns at the river mouth with a really fine scale to then extrapolate that information to the larger body of pit tagged fish, the vast majority of which are not acoustic tagged. John Day steelhead are a summer steelhead, so they migrate over Bonneville Dam primarily from about July 1st through August 31st. Certainly there's a few coming earlier than that and some coming later, but July and August is the peak of migration over over Bonneville Dam, with really the center of that is right around July 31st to August 1st. So steelhead migrate over Bonneville during the peak temperatures of the summer. And so that's generated a hypothesis that the reason that fish aren't entering the John Day River or overshooting is because the temperature is really high in the John Day during summer, which it is. But the steelhead arriving at Bonneville Dam actually spend a substantial period of time in thermal refuge areas or cold water thermal areas downstream between Bonneville and the Dalles dams. And then those fish migrate upstream over the Dalles Dam in September to October when the temperatures begin to cool. And right here, early October, we're at a period here where there's a low pressure front coming through and there's cold air, cold wind, and the water is cooling down. So this is a time period when steelhead are on the move, migrating upstream. But interestingly enough, there's such a massive thermal inertia in the Columbia River reservoirs and the large size of the Columbia that the Columbia River will stay very warm through the fall. So it'll stay in the well over 10 degrees all through fall, whereas the John Day River cools very rapidly because it's a free-flowing stream and is smaller in volume than the Columbia. So at this point in September and certainly by early October, the John Day is now colder than the Columbia by several degrees typically. And so despite that difference with the John Day having colder water at this point in the year, steelhead are still overshooting and migrating past the mouth of the John Day. So clearly there's more to the overshoot phenomena than simply high temperature avoidance. So the exact mechanisms of why steelhead overshoot and where they are in the Columbia and how they're influenced by velocity patterns in the Columbia is what we've been trying to dig into with the use of acoustic transmitters that are placed into steelhead at Bonneville Dam, and then a network of acoustic receiver arrays in the Columbia and John Day rivers that detect those fish and then ultimately build tracks of individual migration patterns of steelhead at the mouth of the John Day River that we can then relate to current patterns, temperature, and other variables like wind and wind surface patterns and flow operations at the main stem Columbia hydro system.